So we're going to find the equations of the tangent lines, plural, to the implicit equation xy plus y squared equals 4 at x equals 3. So there's actually going to be multiple tangent lines because we have an implicit equation. So they'll actually have the same slope, they'll just go through different points. So let's start off by finding those points. We need the y values associated with this x. So if I plug in 3 for x into my equation there, I will get 3y plus y squared equals 4. And I have a quadratic, and so I'm going to get this quadratic equal to 0, and I'm going to write it in standard form, so y squared plus 3y minus 4 equals 0, and looks like we're going to get something that'll factor there into y plus 4 times y minus 1 equals 0. And so there's actually 2 points, so y equals -4 and y equals 1 are going to be the two y values. So we have 2 points this is going to go through. One is 3, -4. One is 3, 1. Now, next thing we need to do is take our derivative with implicit differentiation. Whenever you see an xy product, that's going to be a product rule when we do the derivative. So we're going to hold one of them constant, so x times the derivative of y, which I'm just going to denote y prime, plus y, now I'm holding y constant, times the derivative of x, which is 1. Now y squared, this is a chain rule because we're thinking of y as an implicit function of x. So it's going to be 2y times y prime equals 0. Now, I do need to solve this for y prime. You can, because we're doing it at these points, we'll go ahead and save plugging the points in until last. Let's solve for y prime, and then we'll deal with plugging the points in. So I want to get the terms with y prime on one side, the terms with y on the other. So I got xy prime plus 2y y prime equals -y. So we have y prime times x plus 2y equals -y. We're going to divide both sides by x plus 2y, and there is our y prime. This is basically what's going to give us the slope of each of these tangent lines. One of them at 3, -4, one of them at 3, 1. So let's find each of these. So let's do the one at 3, -4 first. So first thing we need is, now what we need is the slope. So m is going to be, and we're using this equation here, -4 over 3 plus 2 times -4. So that's a +4 over 3 minus 8, so -5, or -4/5. And let's just go ahead and put the line and slope intercept form. So that's going to be y minus y1, which will be y minus a -4 or y plus 4 equals -4/5 times x minus 3. And there's tangent line number 1. Now we need another one going through 3, 1. So 3, 1. So first thing is find our slope. So I have -1 in the numerator over 3 plus 2 times 1 equals -1/5. And so now we're going to have the tangent line y minus 1 equals -1/5 times x minus 3. Now, maybe you're asking yourself, well, how can a function have two different tangent lines at the same point? Well, the thing about implicitly defined functions is they can curve over themselves. So at one point, you could have two different tangent lines with two different slopes.